Hey everybody, this is Larry. This is day 27 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, and let's get started on find right interval. Okay, given a set of intervals, check if there exists an interval j whose starting point is bigger or equal to the endpoint of interval I, which can be called j is on the right of I. For any interval I, you need to store the minimum index, so that okay. Okay, let's take a look at some examples. So, okay. What is the right interval again? Reading is kind of hard for me. Okay. Interval J. Okay. Okay. Minimum right starting point? Still not quite sure what the definitions are. So, there's no 7, 1, 4, 3, 2, 3, 3, what? Each of them check if it's whose starting point is bigger than or equal to the endpoint. Okay, so okay, I think they just didn't define that. Okay, so this is the starting point. This is the end point. I think that's the part that they skipped over and wasn't precise about, and I was just reading it. All right, minimum starting point to build the right. Okay, so basically, because 3 is closer to 2 and 1. Okay. Okay. Do we only care about i's that are less than j or something? Okay, no, that's not true because 2, 3 goes to 3, 4. Okay. Okay, yeah, so I so it took a long time to kind of read this problem correct, and definitely during a contest I sometimes have issues with that because you just want to be as fast as possible, but misreading will cost you even more time as you solve the wrong problem, which I've done from time to time, and hope you don't. But okay. I mean, so basically there are a couple of ways to do this. I think I just have a couple of. Oh, okay. So wait, what does this mean? Meaning that the starting points are unique. Okay. I think I'm still in that understanding the problem stage. Let's put these in the thing first. But I think the one question I have was whether it has to be exactly this, bigger or equal to. So that means that in theory, if you have 1, 2, and then 10, 11, then this should still point to negative 1, 1 or something like that, right? No, I have to. You are kidding me? I have to remove all these things. Oh, I didn't. That's my bad. That was me being silly. Okay, so yeah, 1, negative 1 as I expected. Okay, so then this becomes a problem of for each interval find the number that's bigger than or the smallest number that's bigger than the n interval. That should be okay. I mean, you could definitely do it with a tree or some sort of I think this is actually what you use in C++, but maybe this actually gives me an opportunity to learn something new, because and you can do stuff with binary search, so you can actually manually implement a binary search, and that'll probably be okay. One thing to note is that just a little bit weird, but one thing to note is that because all the starting points are unique, an interval cannot find itself, so you don't have to worry about that weird edge case, if that makes sense, depending on how you, because in some similar problems you may run into something like that. But for me, I do want to find. So one thing that I've been meaning to learn is this thing called sorted containers. and I am going to try to figure out how to use it. I'm reading the API now, so if you want to read with me, this is the link. But basically, for any problems really on Leetcode or wherever you're studying, try to focus on what you want to learn. Even if you know the algorithm, maybe try to learn something new. And for me, sorted containers have been on my list to learn for a long time. So this is a perfect time for me to kind of jump into it. But generally, okay, just to explain the algorithm a little bit, you can do it with a tree, you can do it with binary search, you can do it a number of ways, but it's just a number of queries for, okay, here's a 4, get the smallest left starting point that is bigger than or equal to 4, right? And if you put everything in a list and then you sort it and then you could binary search. So that's pretty straightforward, I think. Implementation may be a little tricky with binary search as usual, but you could do it. But for me, right now, I'm taking the opportunity to upsell, if you will, learning sorted containers, which is something that I've been seeing more and more. And the 3 types of sorted containers, as I'll put it here, there's sorted list, sorted dictionary, and sorted set. I'm trying to figure out which one makes sense the most. Probably not this. Probably the dictionary one, if it has the interface that I think it does. But then now we can maybe, and I'm just playing around, so this may actually be really bad, really terrible. But we're on this journey together. I hope you find something useful while you're here. But for interval in SD, and I guess I have to enumerate it to get the index. Okay, so how do I do this? Oh no, this is intervals. Oops. So SD dot. So we want so this is an interval, which is actually start and end, right? So we want to keep track of the start is equal to. Do we even care about the end? I guess not, actually. No, I guess we don't. So we could actually just do this, and the end doesn't matter except for when we process the answer, right? So okay, and then now we can do it again for let's do this, and then now we can just do, I think, bisect. I always forget which one is bisect left and which one is bisect right, but I think bisect left is the correct one where it can be equal to. So we want to bisect on the end. I don't think this is quite right, the syntax, but let's run it just to see what it gives us. Maybe in general, also, if I had an IDE, I would put this in a debugger or something like that. But this is not defined. I thought someone told me that sorted containers is already automatically defined, but maybe I'm wrong on that one on Leetcode. I hope this is on it, otherwise it's a little sad. Okay, so the 4 finds 3. Did I do this right? I don't know what these numbers represent. That's probably my problem. Yeah, okay, let's print out the like I literally don't know if this gives me the index or the key. I guess the 3 is just representing that it is out of the thing, but and put an end here as well, so we could just have better debugging. And for me, even if I had gotten it right, I would do some printing just so that I could learn more about how the API works, as opposed to me guessing how it works. So now we're looking for 4. We find it in the 3. Does that make sense? And maybe I'm not sure also how sorted dict works with um, bisect. Don't have an idea of it. Applies to keys. Yeah, that's what I would guessed. Oh, so this gives the returns the index to insert the value in a sorted list. Oh, did I look at the wrong one? I want the one for dictionary, right? Sorted dictionary. Yeah, okay. It applies to keys. Yeah, exactly. Okay. But then it gives me the index, which is not super useful, maybe. I mean, okay, this is kind of what we want, but not really. So maybe we don't need a dictionary on this, even though it's a little bit easier to use, maybe. But, why is a key? Maybe this will returns the index as well. Why is it similar to? Apparently, the way to do it, and I don't know about the complexity of this one, to be honest. So, so we might have to, see how that goes. But so that's the index, and you have to do something like sd.keys. If index is less than sd.keys. So something like that. So you're you're watching me learning in real time. Okay. Let's run the code real quick. So that's the way that it seems like you would do it, but it still feels a little bit off. Also, this is just wrong, right? I returned the key, but we actually want the value. So we actually want the st of this. Okay. Because we store the index here, right? Okay, so this looks, well, I mean, this looks good here. Let's submit it. So again, I don't know. I have to maybe do a little bit read up on the complexity of dot keys. Maybe something that internally, like if it iterates through every item to generate this, then that's a little bit sad. If it's just an interface to a pointer that's a sorted list, that's internal representation, which I have to kind of look up, then it's not so bad. But yeah, let's pretend that it does this in the reasonable way. Then in theory, this does everything in so this n items in intervals, and each of these will take all of log n time roughly. So this is n log n. In the same way, this is all of n items, and then each of these will take all of log n times. And I would say in theory this is all of 1. So this is going to be an O of n log n algorithm. Yeah. So this is how and space is gonna be O of n because you just keep one item per interval item. But yeah, that's all I have for this problem. Thanks for watching me. Thanks for watching me learning this problem. This is relatively an interesting problem. I really will have to take a look at the performance to make sure that this is the case, but otherwise this is pretty cool, and I hope that you learned something as well. Hit the like button, hit the subscribe button, and I will see y'all tomorrow. Bye bye.